How's it going, everyone? I hope you're having a great day. This is actually the Soul Foundation in November of 2023. They had a very interesting meetup conference. First of its kind is what they describe it. This is started by Garry, Nolan, and Peter Scafish. And what I'd like to do for this video is just run through really some of the main videos that I've actually gone through and watched, so you don't have to, although I do recommend watching the videos. So let's go ahead and get started. Thanks again for being here. So this is the Soul Foundation. It says, unidentified aerial phenomena hold profound implications for our understanding of nature, humanity, technology, and politics. In November 17th to 18th, 2023, the Soul Foundation held at Stanford University a first-of-its-kind symposium on UAP organized by Dr. Garry Nolan and Dr. Peter Scafish. The meeting assembled leading experts from academia and government to initiate serious, responsible, and cutting-edge inquiry into the phenomena. Okay, so this is Jacques Vallée. He has been involved in UAP for over 65 years, he says. He makes a joke right here at the beginning saying, yeah, if you want someone to finally look into UAP seriously, scientifically, just wait 65 years. He had a few jokes. There they are back in the day. There he is. He said his hair was colored different. Look at this summation of integrals. This was his main point that I got out of this briefing, is basically no one is taking this seriously. So if we look at the cases here, what he says is this is actually your number of reports out of 10 observations, okay? If he says that actually this is what's actually being reported, okay, of the reported cases, this is the category of strangeness, okay? So he says basically most of the actual cases are not being reported. Why is that? Because of this level of strangeness, okay? Because once it gets past the level of strangeness that he says about 4 to 5 is they're not going to be reported at all. So out of the majority of the cases that he believes that are so strange that they're not even being reported of 5, 6, and 7. In this briefing, he says 98% of these cases are reported. That means 2% are not. And 2%, that has been good enough in the past. For Blue Book, 2% was good enough. So not knowing 2% of the cases as being strange or anomalous was good enough because, well, we had 98% of it taken care of. But as Jacques shows here is, as the strangeness goes up, the number of reports is going to drastically decrease. And I can attest to this, okay? The weirder something is, the stranger something is, you will be deemed crazy. And if necessary, they will put you in a asylum, some sort of psychiatric ward. I do think I did benefit from it, but I don't think everyone needs to do that. So this is his main point is we're still not looking into a majority of the cases. Why is that? Because people are afraid to present them. People cannot take them serious. And 98%, well, that's just good enough, right? That's good enough. But as we know from military intelligence is 2%. 2% is going to be an issue, right? 2% will kill you. That'll be the part of the enemy's systems. All you need is 2% of your planes to actually be F-22s, and you can destroy the enemy. Okay, you can destroy the enemy. You don't need that many F-35s to make a serious dent, to make a serious impact in a war. Okay, you only need 2% of your planes to be actually F-35s, is what I would argue, because that's enough. That's enough. Okay, and this is Kevin Knuth here, sitting there. I think I recognize the back of his head. So that was Jacques Vallée's. Again, a link to the main page is down in the description. So if you want to see this interesting conference, go ahead and check it out in the description. So let's move on to the next one. Okay, this is Christopher Mellon. So Christopher Mellon, as it says here, he was the former Deputy Assistant Secretary of Defense for Intelligence, discusses the potential consequence of disclosure to the American public. And this was pretty interesting. So he has basically been the impetus for a large part of this, even my videos, okay? So my first video that went viral was because Christopher Mellon here shared it, and that was when I came out against It's Not a Duck, basically against Mick West, saying, what does Mick West think? We are all idiots as fighter pilots? Are we all idiots? How can we not identify a duck? Then how would we actually fight if we couldn't tell the difference between a duck or an enemy plane or a UAP? So Christopher Mellon, he kind of states in here that he has maybe second thoughts or could be second thoughts about releasing us, right? Releasing people like me into the UAP phenomenon. Is disclosure really what we want? Is full transparency good for the world? Is it good for America? Is it good for national security? That's a main point of his briefing here is that, is it really good for the world? Is it good for the United States? Is it good for national security? And he thinks actually our politicians and our thinkers, not just our scientists, need to be engaged into the phenomenon to really look at this from a perspective of what will happen when disclosure happens. What is the consequences of a disclosure? Could it be something terrible? Could it actually break the underpinnings of our societies and change them? So people like me argue, yes, we should be doing that. Our society, I think, is very sick. You can see we have serious issues, especially in the United States. Just look at the amount of shootings that happen. There's obviously some major issues going on with our society. I think we can get there, and we will get there, actually. I think I'm very optimistic, actually, for the future, especially looking into 2024. We're just going to have some amazing changes, and we need changes, right? But change is scary. Change is difficult. And Christopher Mellon here really going into the details on what are the specifics. And like he says, this is a conference, first of its kind, of scientists. And yes, we do need scientists engaged in this, but we also need our other thinkers. We just need it to come out of the woodwork. And yes, I think transparency is good. Transparency is good. Ultimately, it will be good, okay? Integrity first, and transparency does last forever. I think that really is a point, and our government needs to be more transparent. We need to stop running around in a zero-sum world and killing people, right? I think we should be more invested in bringing abundance to the world, bringing energy abundance, bringing food abundance, reclimatizing nature, renaturing our environment. And so, again, the main point of his is, can we think through this a little bit more and bring it out of the kind of the backwoods, right, of where UAP is. We need to be discussing it, and not just scientists discussing it, but we need all of our thinkers to actually discuss it. So thanks to Christopher Mellon. He hasn't come on my show, so I don't know if he's really happy about how I present, but I'm in it for transparency. And I think, yeah, the government can do what it wants, but it's going to be civilian efforts like this one, like the Soul Foundation, that are going to force the government's hand and going to force transparency. If we can find the information out on our own, then it will force their hand. Okay, next one will be Garry Nolan, PhD. Okay, so he's basically been the driving force behind the Soul Foundation, and he talks about the material science of UAP. So my degree was actually in material science, which is understanding what matter is. What is matter? What is all this stuff that we're looking at? Again, there is Kevin Knuth. His was the most interesting briefing, I thought, Kevin Knuth, out of the ones I watched. And so I'll cover that last. But let's go through. Garry Nolan had a very interesting couple cases, actually, that he brings up. So if you've seen any interviews from Garry Nolan, he's a world-famous scientist. He is rich, apparently. His argument is, how would you actually investigate? How would you actually analyze UAP? And so he says, data is something unusual is observed, evidence is collected like in a crime scene, then we need a hypothesis that these materials came from the object. Okay, so that is his hypothesis. And his main point is, these things are anomalous, these are offside cases, these are the extremes, and that's where you actually learn, right? We actually learn from the extremes when our models break down. And that's when we have to create new models that are more accurate, more precise. So he goes through how to actually fingerprint a UAP material, and he uses ChatGPT. I love all these scientists are starting to use ChatGPT, and he uses ChatGPT throughout this presentation for these pictures that he actually comes up with. So how to fingerprint a UAP material. So he's talking about physical and chemical analysis. What is the material composition made of? And he looks at it, we'll go through here, he looks at it at an elemental and molecular level. Structural analysis, microscopy, and atomic dissection for structural details. So if you look down at the atomic level, what are these materials? Why are they interesting? He looks at a functional analysis, so energy source identification. Can we figure out where it actually comes from, the energy source? And then signal analysis, electromagnetic or other signals, interaction with the environment. So monitor responses to stimuli and collaborative research. So he basically has presented this Soul Foundation, and it's really to have an avenue, some sort of avenue to start analyzing the UAP materials. And they have a paper that's quite interesting. We'll cover the paper briefly. It's the data, not the conclusion. So verifiable data and methods are what are peer reviewed, and really we don't have that. Okay, so that's what he's trying to do that. So here's where we start. Here's another ChatGPT created image. You can tell that, right? And soon we won't be able to tell that it's ChatGPT created, but that is obviously. So this is the paper, improved instrumental techniques, including isotopic analysis applicable to the characterization of unusable materials with potential relevance to aerospace forensics. So let's go check out that paper right now. Okay, so here it is, improved instrumental techniques, including isotopic analysis. So that's what he really goes through in the paper is the isotopes, and we'll cover what isotopes are. It's really just different versions of the same element, okay? This is Garry P. Nolan and Jacques Vallée. So I already covered Jacques Vallée, along with Suzanne Zhang and Larry Lemke. Sorry if I read that. You have to request a copy directly from the authors. Okay, that's unfortunate. But let's look at the abstract here. So the abstract, the problem of precise characterization, analysis, and eventual identification of unknown materials, okay, arises in many fields and takes many forms, depending on the nature of the substances under study. So yes, it's very difficult to actually identify what something is. How can you tell that something is anomalous? In the first part of this paper, we review common modern mass spectrometry techniques applied to such studies. So I did mass spectrometry when I was in my actual university, so the Air Force Academy, and that is, we go through it a little bit, but to identify what is in a material at the atomic level. We also give an overview of improvements made to these technologies in recent years by Silicon Valley companies and other teams focused on precise biomedical research. So that is Garry Nolan's. He actually worked through cancer, dependent upon sensitive techniques, yet applicable to a wide range of non-biological materials. So Garry Nolan is trying to take his specialty and bring it into the UAP phenomena. In the second and third parts of the paper, we review practical experiences applying these techniques to the simplest case of characterization of solid materials, as opposed to liquids or gases, and comparing our results with previously undertaken isotopic analysis. In particular, we describe our correlations of that analysis with the patterns described by witnesses in a well-documented, still unexplained incident. So he goes through three of them, initially thought to be of aerospace origin, which gave rise to the deposition of unknown material, and by the investigators who handled it in the field and the laboratory. The lessons from this specific investigation are applicable to a wider range of issues in reverse engineering of complex esoteric materials and aerospace forensics. So he goes through what I believe are three cases, and he got the materials from Jacques Vallée, as I believe. Okay, I'm sure I would like to read the full text, so if you guys know where I can get that, then let me know in the comments. Let's get back to Garry's briefing. Okay, so he goes through kind of three interesting cases. This first one is Big Lake Park, Council Bluffs. This is from 1977. Again, these are famous cases. Primary observers, Kenny Drake and Randy James. So Kenny was 17 years old. His nephew, Randy James, 12 years old, were driving on North 16th Street when they observed the phenomenon. Kenny's wife, Carol, 16 years old, was also in the car. Mike and Chris Moore, a couple. Mike Moore, a 24-year-old parts man at an auto dealership, and his wife, Chris, a 24-year-old legal secretary, observed the object from Broadway Avenue. So basically, primary observers, different ones. The observations were a reddish ball at an estimated altitude of 500 to 600 feet, falling straight down into Big Lake Park. So reddish ball falling straight down, and a hovering object. Mike and Chris Moore reported seeing a round object with red lights blinking in sequence around its periphery, hovering in the sky below the treetops. So those are your two different observations. One sees a reddish ball, estimated 500 to 600 feet, falling straight down. And then another group of people, Mike and Chris Moore, reported seeing a round object with red lights blinking in sequence, hovering in the sky below the treetops. Their immediate reaction, the police and fire departments were alerted, responded to the scene. Subsequent investigation and analysis of the incident characterized by a discovery of a large mass of molten metal and the lack of a clear explanation for its presence. Okay, so this is an image. He has an image from it, the mass of material, okay, and some of this material was taken, samples are taken, 1977, I think, through Jacques Vallée. This got back to Garry Nolan, and they throw it in mass spectrometers and start analyzing it. So they go to Council Bluffs, and what they do, multiplexed ion beam imaging. I guess this is similar to mass spectrometry, basically you're shooting beams at this, ion beams, okay? And it scans a 2D surface by hitting it with a beam of primary ions. It's like a sandblaster. Secondary ions are collected and their mass determined. So you're basically just sandblasting it and seeing what comes off of it. It looks like mass spectrometry, okay? This is what spectrometry looks like to me, okay? You're going to get at different levels based on how it reflects, okay? How that primary ion beam reflects, it's going to tell you what's in the material at the atomic level. And this is what we're looking at. How do you actually analyze these materials? How can you prove? Okay, what's interesting here is he gets different samples, okay? And you get weird isotopic analysis, okay? So what are isotopes? Look at this. Okay, so if you look here, manganese, there's only 55. That would be protons and neutrons. So when it changes, okay? Magnesium, okay? 24. If you look at the isotope, that's how many protons and neutrons are in the sample, okay? You can have more neutrons in a sample, but if you add another proton now, it's going to turn to a different element. So aluminum, there's only one isotope of aluminum in this sample, okay? But silicon, you have 3 different isotopes, so 28, 29, 14. This is like carbon, right? Carbon normally has 12, but you can have carbon 14. Carbon 14 is actually what they use to time date old materials, right? Carbon 14 is radioactive and will actually decay. So isotopes decay. So it's not so simple. You can have different number of neutrons. And again, I think our understanding of material science is about to change radically. It's going to change radically when we actually know what is going on at the quantum level. So he says here they get a different breakout from Council Bluffs, okay? And what's interesting is the isotopic analysis, okay? He shows here what was interesting about kind of all these samples is it's inhomogeneous. What does that mean? If you get a mass of molten liquid, right, a mass of molten metal, you expect that it's all of the same material. You would think it to be homogeneous, okay? But what they found in all these samples, from what I can tell, and from the 3 different cases, is that it's actually inhomogeneous, okay? Inhomogeneous, kind of like it wasn't correctly mixed. It wasn't mixed. So you hear aluminum 27, okay? Silicon, iron, and magnesium. And what you find is they're not mixed. It's inhomogeneous. That was quite interesting to me, that it's actually inhomogeneous. So the conclusions are, all of these really is clearly a result of an industrial process. You have incomplete mixing of the components and no signs of remaining technology. So in none of this was there any sort of technology left in any of these 3 cases that he brings up. And there was no exotic isotope ratio. So nothing exotic. The most interesting thing about this is it was inhomogeneous, so improperly mixed. How can you have molten metal that's improperly mixed? But like you said, it's clearly a result of an industrial process. So he goes on to say they're actually having improvements. Okay, so they have improvements. This is a new system where you essentially turn it into a gas and then see what comes out. Okay, see what comes out. There's different techniques, and what he gets is kind of this cool molecular mixture. So what is actually in it down to the atomic level? This is the sort of accuracy that Garry Nolan is aiming for. He wants the rest of the scientists to go to that level of accuracy. And what it can tell you is at the atomic level, it can tell you what are all these different strange elements in it. Right? You're going to see at the atomic level and how it's mixed, how it is actually mixed. So the materials show no sign of technology, but the material is, again, clearly a result of an industrial process and, again, incompletely mixed. So incompletely mixed, another interesting part. All right, we go to Ubatuba. So another famous incident reportedly took place in the 1950s, the most cited date being 1957. The primary witness was a Brazilian journalist named Ibrahim Sued, who received physical evidence from an anonymous source. Okay, that's unfortunate. Physical evidence. The evidence consisted of metal fragments claimed to be from a disintegrated UFO. The actual incident, according to reports, a UFO was observed over the beach at Ubatuba. It suddenly exploded, scattering metallic debris. So the analysis of the fragments, initial examination suggests the material is highly pure magnesium, with some studies indicating an unusual level of purity, potentially not typical of terrestrial manufacturing processes at the time. So again, this was in 1957. So here it looks like what I'm used to is a spectrometer, mass spectrometry, and they have the 2 samples here. Garry goes into detail on how they actually get the samples, and they actually put more than just this one from Ubatuba, okay? So they have more data. And what's interesting here is the isotope ratios are different. So one sample had normal isotope ratio. So if you look here, so magnesium 24, 25, 26, these are the natural breakouts of it. Okay, 78.9%. 10% is going to be this isotope, magnesium 25, and 11%, 11.1 is going to be magnesium 26. Okay, so shard 1 and shard 2 had the same. So matching your natural kind of isotope ratios, okay? But what was interesting is the other sample was very different. So shard 3A and 3B were off. So 66% was magnesium 24, 15%, so you had almost 50% more of magnesium 25, and 100% more of magnesium 26. So your breakout, your isotope ratio was different from your natural elements. So why change the isotope ratios? Especially in 1957, this would have been extraordinarily expensive to make, says Garry Nolan. Humans have no current reason to change the isotope ratio. So again, why would you have this weird isotope ratio? He talks about here about isotopes. This is where we talk about iron. Okay, so iron, it will be, as we consider it, the same element, but it will have a different number of neutrons. Okay, what are neutrons? They're basically protons, but with no charge. Again, I think all of our material science, all of our science is about to change radically as soon as AI actually gets involved. This is Ubatuba again. He said you also have what's silicone. Okay, you had extremely pure silicone. He goes in here 99 over 99.93% pure silicone, okay, which is quite interesting. 99.96% pure silicone. How could silicone be that pure? I mean, we can do it. We can make it that pure, but why would you just find this random out on the beach? He goes here, this is the level that they're looking into it. Okay, this is your silicone ratios, so 28, 29, and 30. And again, he says, why would you have this sort of engineered silicone? Just from a random sample, why would you have it that pure? And this is the level that he's looking into it. Okay, you actually see the breakout of aluminum. Those are the aluminum molecules and the actual silicone in there. You can see the actual breakout of it. So from Ubatuba, the materials show no sign of technology, but the material, again, is clearly a result of an industrial process. So clearly a result of an industrial process that we don't understand. Unusual level of pure silicone with contaminants. So what are the contaminants? It looks like if it was an industrial process, those contaminants were put in on purpose. And why would you have that high level of pure silicone? His argument again, why? Okay, this is the third case now. Date and location, April 24, 1964, near Socorro, New Mexico. I believe this is from Jacques Vallée. Zamora observed a flame and heard a roar, leading him to investigate. This is a famous case, again, described as shiny, whitish, aluminum-like, and O-shaped. The object was about 150 to 200 yards away. Zamora saw two individuals in white coveralls near the object. He was a police officer at the time. The object's activity, it was emitting a blue and orange flame. The object ascended and rapidly moved away. So as Zamora approached, it took off. According to Zamora, there was smoldering grass and brush found at the site, and later an object. So later an object was found. Zamora's later life, he eventually avoided public discussion of the incident and changed professions. Okay, this is from Socorro. And what's interesting here is you have this definite line, okay? This definite line between zinc and aluminum. I believe aluminum's on the top. This looks like aluminum, actually. But you have again, industrial line. Like, why is this so clear? As Garry says, this is from a process, okay? There was some way to get it this, they're connected, but completely different, okay? So what caused this and why? You see again here how the materials are organized between the aluminum and the zinc. Down to the atomic level, that's what he's looking at the atomic level. So cool. Okay, yeah, the aluminum's on top and the zinc is on the bottom. And look at that level. Almost pure aluminum to almost pure zinc and connected. Why are they connected, he's saying? And even at the atomic level, okay, because there is some contaminants again, but not homogeneous. Okay, so this is not homogeneous at the atomic level, if you imagine. Some of these little aluminum molecules are interspersed, but again, not well mixed down at the atomic level. And these are all the new methods, okay? So all the new methods, let's pause it here and look through. So transmission, this is an electron microscope, scanning electron microscope, STEM, I've used a couple of these. You have a tunneling microscopy, again, electron microscope, super resolution optical microscopy, electron energy loss spectroscopy, field ion microscopy. Okay, so many other kinds of atomic imaging. So there's many other ways to actually analyze these materials. And he wants to set up a pathway to make that happen. What does he call it? He calls it Stardust. So the Stardust repository, everything is made of Stardust, he said. He wants to make a pathway to get standardized testing with a federation of labs and analysis tools organized under public umbrella, okay, so we can keep it transparent, funded by gifts or grants if anyone wants to donate and help out. This is a great way if you want to get the science involved, and data is freely available at once or after an owner writes a paper, but within 1 to 2 years. So still going to take a while, okay? So science takes a long time if you want to do it correctly. Okay, and then finally, what I consider the most interesting out of all of these is going to be from Kevin Knuth. So Kevin's argument, his main point at the beginning is that we don't even have a actual model of quantum gravity. Okay, so we can't even decide on what gravity is. And I totally agree that physicists assume we know everything, right? That's kind of the assumption when they talk about their theories, etc. But there's not even a model of quantum gravity. There's no way to link quantum mechanics to general relativity. There's not even a good model, okay? I presented one, was called crazy for it, but there's not even a model, okay? So physicists have no clue what they're talking about, okay? They have their heads so far up their PhDs, I believe that they're missing the forest for the trees, okay? So UAP are a class of phenomena, not a single thing. And he says here, multiple hypotheses are likely to be found to be correct. We should expect confusion resulting from similar but different phenomena. So basically, physicists should open their minds. His recommended strategy, okay? Reduce probability of error, divide and conquer. The extraordinary hypothesis. Again, we're going to learn on the outside, on the outskirts. Where do we actually break through our theories? Is when our models don't make sense. Okay, when our models don't make sense, that's on the outskirts. So UAPs are an amazing way to actually find new hypotheses. And he says, remain agnostic with respect to the hypothesis. So again, don't assume that you know the answer. We don't know the answer. Our physics is broken. Okay, our physics models are not there right now. We have no even model for consciousness, the one thing I think we can agree on. And we have no model, not even a good estimate of linking general relativity to quantum world. Okay, there's not even a good model. So stop thinking that you know the hypothesis. Stop saying that our physics is done. It is not done. Okay, it is certainly not done. So he has a great list here of the 5 observables. This is probably where we should start. So positive lift, sudden instantaneous acceleration, hypersonic velocity without signature. So this means no sonic booms, okay? Transmedium travel, able to go through the water. He brings up Aguadilla. Low observability or cloaking, and then biological effects. Again, this is the most interesting briefing I found. So if you are going to watch one of these all the way through, I recommend this one. He talks about here about, this is the Nimitz, okay? And he's said before, we have actual recorded data, right? Radar data that, well, we can't see, but Kevin Day states 28,000 feet down to 0 feet in 0.78 seconds. So he says here the amount of energy that would take, okay? The amount of energy is astronomical, literally astronomical. Why do we think these are spacecraft? Is because they use energy and speeds of spacecraft. So if you determine that the weight, okay, force equals mass times acceleration, okay, force equals mass times acceleration here. If you use the mass of an F-18, and he didn't even use that, he used 1,000 kilograms, so 1/10 of the mass of an F-18. Okay, if it did this maneuver, 28,000 feet to 0 feet in 0.78 seconds, that would be 1,100 gigawatts. That's more than 10 times the total nuclear power output of the United States. That is amazing. So an amazing amount of energy. So what do I believe? Assuming these numbers are correct, right? And why would they be wrong? I would say that there must be a way that our mass goes to zero. Okay, if your mass approaches zero now, you can hit these accelerations. And also you'd be able to stop. So I think there's some way with light that the actual mass goes to zero. So he relays that. Next interesting point here, it talks about is Hermann Oberth, the German father of modern rocketry. Okay, he's the mentor to Wernher von Braun, who actually came to the U.S. All right, oh man, so sketchy. Look at that. I mean, Nazi scientists started our nuclear program. And what he says is a lecture about flying saucers. Hermann Oberth in 1954 said their speed is sometimes very high, 19 kilometers per second, measured with wireless measuring instruments. So that's with radar. Accelerations are so high that no man could stand it. And it's not like we just had 3 or 4, right? If there would only be 3 or 4 measurements, I would not rely upon them and would wait for further measurements. But there is existing more than 50 such measurements. This is from 1954. 42,500 miles per hour, more than 50 such measurements. The wireless sets of radar of the American Air Force and Navy, which are used in all fighters, cannot be so inaccurate that the information obtained from them can be doubted completely. This is the same information we have now. I just want to say that nothing has changed. Like Jacques Vallée said, just wait 65 years, and we need even more than that. Even more than that. You're looking at 70 plus years. Okay, amazing stuff. And we're seeing the same things now. Okay, and we're still arguing that we don't know what it is. Okay. He relates through radar observations at Minot Air Force Base, 1968. This is quite interesting. During the early hours of October 24, 1968, 2 glowing UFOs were observed at Minot Air Force Base, North Dakota, and that supports nuclear ICBMs. That's relatively similar to Maelstrom Air Force Base, and that's where Solace talked about. So at 3 a.m., an approaching B-52H was alerted to watch for bright glowing orange UFOs. I believe the H is the nuclear one. During a 180-degree turnaround, both ground and B-52 radar systems detected an object maintaining 3 miles of distance from the airplane following its descent rate. It probably had a nuke on board. Within 1 3-second sweep of the radar, the UFO closed 2 miles distance, positioning itself only 1 mile away from the airplane, pacing it for 20 miles. So that's at least a couple minutes, right? Probably 3 minutes there. The plane banked and flew over the UFO, which was egg-shaped and glowing like molten lava. The acceleration to close the 2-mile distance was found by Claude Poher to be 209 Gs with a top speed of Mach 12. So again, 15,000 kilometers per hour or 9,200 miles per hour. Again, spaceship level. You know, how can you do that? I would argue you would have to have your mass down around 0. It brings up another one, 1986. JAL Boeing 747 Flight 628 was flying from Tokyo to Paris when it encountered several UFOs over Alaska. A large UFO about the size of an aircraft carrier followed JAL 1628 for approximately 50 minutes. That's 50 minutes. Summarized by Knuth Powell in Reality 2019 in a paper, it was more carefully analyzed the radar data of the large UFO's motion. At 269,000 miles per hour, again, it could have reached the moon in 53 minutes. That's why he says these are spaceship numbers. So we have data that these are just amazing, amazing numbers. One key point, he says no energy deposition when decelerating or stopping. So these things are moving. I argue they're moving like light. It's moving just like it was light. Okay, no mass. It brings up other cases. So we're talking about hypersonic speeds, extremely fast, not even hypersonic, faster than hypersonic and immediate. But some UAP are extremely luminous, so much so that photographs are difficult to interpret. So the amount of light coming out of this image here on the left should have lit up the clouds, okay, based on the amount of light, he argues, unless it was pointed directly at the camera. So where is this light coming from? How can you have so much light there? It's from 1956. You have other ones, extremely luminous, as in amazing amount of energy coming out of these things. He relates here like the amount of energy that would take is just unbelievable. So again, luminosity estimates. What's the purpose of emitting hundreds to thousands of megawatts of light? Could that be that energy disposition that he's talking about? Maybe it has to actually get rid of that energy. If this is merely a byproduct of the propulsion system, then it is shocking and telling that wasting megawatts of power is an acceptable loss, like megawatts of power. Okay, and then he goes through electric and magnetic fields. So again, these have been measured and you can see different results from it. So what's interesting here is what he talks about is car engines go off and sometimes come back on. So how could this actually happen? Could this be real physics? His argument is yes. Okay, if you have an amazingly strong magnetic field, it will actually stop the spark plug from working. In half of those cases, 10%, the piston is prepared to fire and the engine restarts. So this is how you could have a car actually come back on. He says this is known physics, okay, but it requires extremely powerful electric fields, ionizing the air, shorting out spark plugs and distributor caps. And he says according to actual reports. So people reporting what happens 10% of the time, the car starts back up on its own. How could this happen? Through normal physics. But you need an amazingly powerful electric field on the order of 3 times 10 to the 6 volts per meter generated by a small UFO, amounting to more than 10 to the 9th joules of energy. So amazing amounts of energy, amazing electric and magnetic fields. But you can see these optically, okay? If you have a polarizing filter, this is quite interesting here. So light from the sky is polarized in cases where UAPs are generating huge magnetic fields. Okay, so huge magnetic fields, polarized light is rotated. This is the Faraday effect. This can create rings of varying intensity. So Faraday rings when viewed with linear polarizing filters. So you could actually have a filter, okay, a linear polarizing filter over a camera and actually take pictures of the magnetic field generated. This would be quite interesting to put on any sort of UAP detectors. There are claims that this has been observed with UAPs. And this is the most replayed part of the video, trans-medium travel and affinity for water. So he says a lot of these are actually over the water. A lot of them are seen sucking up water. He mentions a case there. And this is Agudia, actually where it goes through the water with no issues, seems to have no problem, almost again like light. Again, I argue these UAPs act like light objects. And finally, he relays a very interesting encounter here from 1987, 175 miles northeast off the tip of New Zealand's North Island. HMN New Zealand's Southland was involved in daily exercises designed to draw USOs in from the Pacific Ocean. Quite interesting. It was followed by a large USO, which beamed 150 feet wide and 800 feet long, so 30% larger than the Typhoon-class submarine. So giant undersea object. The USO followed the Southland at a distance of 20 kilometers, so it was impacted with sonar. So actually sonar was bouncing off this thing. It tried to shake the USO, making sharp turns at 28 knots. The 800-foot USO closed to the 20-kilometer distance in about 30 seconds. A minimum speed underwater of 1,500 miles per hour. A minimum acceleration of 4.5 Gs. So the USO acted as if it did not interact with the water. However, the sonar, which relies on pressure waves, measured its position and speed. And these are a list of transmedium travel UFOs that's been observed and recorded. And Knuth, Kevin here says for over 140 years. So look at all these. For over 140 years, you're seeing unknown objects into the sea, going into the sea, large luminous spinning wheels. Again, with the 6 observables now, the 6th observable was biological effects. Could it be biological effects from these amazingly strong electric and magnetic fields? We should pay close attention to the other ocean worlds as well in our system, okay? So we should look more at our own oceans, which is most of the Earth's surface, okay? It's going to be oceans. He says we don't have actual good coverage of satellites over the ocean. Maybe that's where we should start looking, as well as paying attention to other ocean worlds in our solar system. Okay, exciting stuff. UAPX, who Kevin works with, they have a lithium-powered nuclear fission reactor that supposedly Sadagus created. You can just hold in your hand. I'm very curious to see what that looks like. That'll be very interesting to lure in UFOs, UAPs, and USOs. Okay, so that's it for this video. I hope you guys enjoyed this quick summary. I'd recommend you go and check out the Soul Foundation, their YouTube channel. I haven't watched Diana Pasoka's presentation yet, but I'm reading her book, Encounters. It's an amazing book. I've also interviewed Timothy Gallaudet there. Amazing to see this Soul Foundation out there. Go ahead and check that out, guys, if you want to get any more information. Again, I think Kevin Knuth's briefing was the most interesting, but so far they've all been interesting. Thanks to Garry, Nolan, and Peter Scafish for setting this up. Thank you for actually watching this video. Please like it. If you did like it, share it with your friends and subscribe to get more content. If you want to support the channel, go to patreon.com/chrislehto to support the channel. I throw up other types of videos on there, and you can also join as a YouTube member here. I'll be doing a YouTube member only live stream next week. Have a great weekend. Hope you guys are doing well. Take care. Peace.